All right, this is the fourth and last video of the Week 15 test, and this is on constant of variation, concept 13.2. As you can see, this is a C-level problem, and what that means is it won't be on any more regular weekly tests. However, you can go ahead and take it on an intervention test, do some studying on your own, whether that's tutoring with a friend, whether that's watching the 3 videos about this concept, and then come back and let me know, and we can set up a test time for you. So anytime we're looking at constant of variation, we are looking at the relationship between the 2 items. Here's what we know about the relationship between these 2 items. We know that the number of times wheel B spins varies directly with the number of times wheel A spins. So A spins along, and the number of times it spins controls how many times wheel B spins. That means that wheel A is the independent variable. That's the one that just spins along, spins along, spins along. Wheel B is the dependent variable. How often wheel B spins, right up here, how often wheel B spins varies directly or depends on the number of times wheel A spins. Our relationship for constant of variation is we take the dependent amount and we divide it by the independent amount. And that will give us the constant of variation. And that's true for any of the relationships that we pick. So if we pick this relationship, the dependent is 8, the independent is 6. When we do that division, we get 4/3. It's also true for this one. The dependent is 16, the independent is 12. When we do that division, we get 4/3. It is also true for this one. The dependent is 20, the independent is 15. When we do that division, we get 4/3. It doesn't matter how you pick your points, they're all going to be the same. 12 divided by 9, 4/3. 24 divided by 18, 4/3. So for this particular problem, the constant of variation is 4/3. Now, if you switch that form, if you change that form to 1 1/3, or you change that form to 1.3 repeating, those are both correct answers also. You don't have to do that. Remember, we're past that elementary school level where improper fractions are always wrong and need to be simplified further. Improper fractions are perfectly valid answers now. All right, the second part of this problem says write an equation you could use to find the number of times B spins given the number of times A spins. What they're asking you to do is to solve for B. If you're finding the number of times B spins, you're solving for B. So what you know is B will be alone. All right? You're going to have B equals something, or you're going to have something equals B. There won't be any constant with the B. It's a 1. So what's the relationship? Well, if you take the 6 and you want to get the 8, you have to multiply by the constant of variation. You have to multiply by the 4/3. Same thing down here. It could be 4/3 A equals B. It could be one of these others. If you had selected this other form and you wrote it as 1 1/3, all right, it could be, let me just clear that up a little bit so it's easier to read. There you go. It could be 1 1/3 A equals B. It could be B equals
1 1/3 a. The form of this value, the form of the constant of variation, does not matter whether you show it as a fraction, whether you show it as a mixed number, or you show it as a mixed decimal. The key is you're solving for b. So if you're solving for b, the b has to be alone. All right. And that seems to be the thing that has thrown most students off. They're able to find the constant of variation, but they're not able to write the equation because they keep writing for the wrong thing. They keep solving for a. Look at it carefully. If it says find the number of times b spins, then you're solving for b. All right, so match your test up against this. And then if you have questions, you need to ask me, before you're ready to take a test. That's great. Bring me some questions. And then once you feel confident, and once you feel you really know how to do this, we'll set up a time for you to come in and take a retest. All right, great. I'll see you in class.